Good morning, everyone. First of all, I would like to thank the Romanian Society of Ultrasound for selecting me and selecting this presentation to represent them at the Eurozone 2020. My topic today, which actually it is part of my PhD studies, it is about the potential of gold nanoparticles used as concomitant agents in radiofrequency ablation. All of these techniques have been greatly improved over time. Actually, in the last decade, there were a lot of improvements. We now have new radio frequency or microwave generators. We have new electrodes. We have new ultrasound machines for guidance, like SEALS guidance, or more recently, fusion guidance. And of course, over time, we now have a lot of experience, at least in our center, with more than 1,000 cases performed until now. However, in the last decade, there were a lot of great improvements in the field of thermal ablation. We have new generators, we have new electrodes, we even have new ultrasound machines. We also have new guidance systems like SEALS, like fusion, and of course, we also got a lot of experience over time. However, unfortunately, the 5 years recurrence rate has not changed that much over time. And with all the great improvements in the thermal ablation field, we can still not treat tumors greater than 3 centimeters. Nevertheless, ablative margin is also important, as we have recently shown here. An ablative margin of at least 5 millimeters is essential for a better local tumor control. Therefore, if we want to treat larger tumors, for instance those between 3 and 5 centimeters, or if we want to increase the ablative margin size, then we need to search for alternative solutions. In this study, we launched the hypothesis that PEG-coated gold nanoparticle administration during radiofrequency ablation will increase the coagulation volumes in liver. Why did we choose gold nanoparticles? Well, first, gold nanoparticles are easy to synthesize. Gold nanoparticles have already been tested in clinical trials, and gold is an excellent conductor of thermal energy. I'm not going to enter into details about synthesis, cytotoxicity, and physical properties, since this data has already been published by one group from our university. This was an in vivo study. We used 10 sus scrofa domesticus and we did 3 ablation in each pig. 10 ablation with physiological saline, 10 ablation with gold nanoparticles at a concentration 10 power to 10 per milliliter, and 10 ablation with gold nanoparticles at a concentration 10 power to 7 nanoparticles per milliliter. All the solution were injected during the procedure through the internal channel of the electrode. We use general anesthesia and of course ultrasound guidance. The Logic E9 from General Electric. The ablation time was 6 minutes and the needle was deployed to 3 centimeters. We used actually an old radiofrequency generator, as you can see here, the RITA system. And the electrode used here was an umbrella type with 9 electrode tines. After each ablation, actually 10 minutes later, we performed a SEAL examination to evaluate the coagulation zone. We kept the animals alive for 5 days, and on day 5 we performed another SEALS examination and evaluated again the coagulation zone volumes. After second SEALS, all animals were sacrificed and the coagulation zones were measured in 3 axes using calipers. We measured the length, the width and the height. And the coagulation zone volumes were estimated with the equation of an ellipsoid volume. And here you can see some macroscopic findings on figure A. It is actually a photograph of the liver surface, and the figure B, it is a cross-section image. Both of them are showing a large central paleo zone, which we define as the white zone, surrounded by a dark red rim, which actually we define it as the red zone. On figure C, as you can see, we have no tissue chairing. This ablation zone, coagulation zone, was performed with gold nanoparticles, and on figure D, you can see there the white arrow. We do have tissue chairing. This ablation coagulation zone was done with physiological saline. Also, macroscopically, we could clearly identify and see that gold nanoparticles treated coagulation zones were higher compared to physiological saline treated areas. And as you can see here, the coagulation zone volumes in N1 and N2 were more than 2 times bigger compared to physiologically saline treated zones, and this difference was statistically significant. However, we did not notice any difference between N1 and N2. And here we have a Zeus example. You can see a coagulation zone treated with physiological saline, which is obviously smaller as compared to N1 treated zone. Actually, N1 is gold nanoparticles treated zone. In this table, we have the coagulation zone volumes as evaluated by Zeus immediately or on day 5 after treatment. You can clearly see that N1 and N2 coagulation zone volumes are statistically higher as opposed to physiological saline. Interestingly, on day 5 there was an increase in the coagulation zone volumes. However, the magnitude of the increase was similar irrespective of the type of solution used, physiological saline or gold nanoparticle. Here you can see a hematoxylin stained image. We have the white zone, double head arrow, and the red zone, black and white asterisks. What's more importantly, there was no difference in red zone width, and there was no difference in inflammation grade. Our study does not lack novelty. It is the first study evaluating the potential of gold nanoparticles to increase the coagulation zone volumes. Gold nanoparticles have already been tested in clinical trials, and of course our approach is very close to clinical practice. However, there are also some limits. First, we could not monitor the target tissue temperature since our in vivo design, and second, we did not evaluate the fate of gold nanoparticles. Instead of a conclusion, I would like to thank the FSUM organizer for this nice online session. I would like to thank all the participants, and if there are any questions, I will gladly offer some answers.
I'm Damiano from Italy. It is a real pleasure for me to take part in this European Congress. Even if only online, this Congress I think is the proof that we are stronger than pandemic and that science never stops. In this particular period, ultrasound has represented a valid way to make a diagnosis in our patient affected by COVID-19, and ultrasound has proven to be an ally, an important ally for the physician all over the world. So we realize the importance of ultrasound in this emergency period. But now the time is going. It's for me a big pleasure. I'm very proud to introduce this study about the effects of diet and nutraceuticals on patients with metabolic syndrome and liver steatosis. We know that between these two aspects, the metabolic syndrome and the liver steatosis, there is an interconnection, a sort of vicious circle, we can say, because the metabolic syndrome feeds the fatty liver disease, which in turn is a part of metabolic syndrome, as we can see in this slide. And fatty liver disease is actually a spectrum multiple disease with a possible progression to liver fibrosis. Fibrosis is the most worrying phase and is the result of a network of cytokine activation that also involves the immune system and the adipose tissue. And in this context, ultrasound represents a fundamental imaging tool in the study of liver steatosis. Maybe only MRI can have a comparable diagnostic accuracy, but we know with all the limits of a second level imaging technique. And at the same time, the elastography represents a useful way to evaluate the liver stiffness, and so in particular share wave elastography that we used in our university in Italy. And so we had the idea to perform liver elastography in patients with metabolic syndrome and fatty liver disease, looking for variation in liver stiffness after diet and change of lifestyle, with also an evaluation of liver steatosis on B-mode ultrasound and variation of laboratory exams. So we considered a cohort of 63 patients. We excluded 45 patients who had other causes of liver chronic disease, and we studied 18 patients with fatty liver disease, metabolic syndrome, diagnosed according to the criteria of International Diabetes Federation. These patients were divided into three groups. The patient of group 1 followed a diet and exercised moderately. Patient of group 2 and group 3 received in addition to change of lifestyle some nutraceuticals, as you can see in this slide. The patient characteristics, the characteristics of the patient were between 40 and 63 years old, were those of having an high BMI, a significant circumference of neck, waist and hips, significant visceral adipose tissue, but also blood pressure values at the upper limits of the norm. So we evaluated laboratory markers, steatosis through ultrasound B-mode and stiffness through elastography, and the results were not significantly different between the three groups I described before. So we therefore considered the 18 patients as a unique whole, and found that after 4 months of treatment they had a significant reduction in weight and BMI, significant reduction in circumferences, in visceral adipose tissue and in the blood pressure parameters, but also they had an improvement of laboratory parameters such as the total cholesterol, the LDL, glycemia, and the insulin resistance index. But the most important part is that we found a reduction independently from the group of the patient, reduction in liver stiffness, in the degree of hepatic steatosis with B-mode evaluation, and even a reduction in liver size, as you can see in this table, but also in these figures presented in the slide. So that's the most important characterizing part of our study, and we think that the future in the future we can establish a role of screening and follow-up for patients with metabolic syndrome and fatty liver disease. Ultrasound and elastography can be useful techniques to manage this patient, and to follow up this patient, to understand if they are improving from a metabolically point of view. But also we think that we need to codify a scale of stiffness values associated to histological grading in metabolic liver disease, as we have for hepatitis C, for example. Thank you for your attention, but at the end of this presentation I would like to thank all the colleagues who have been involved with me on the coronavirus front. It was a touching experience from a professional but also from a human point of view. We didn't think we could do it, I'm honest, because the pandemic came like a tsunami in Italy, but we did our best and made all our expertise available, including the use of ultrasound that was very precious. And so thank you of all, never give up, and greetings from Italy. Thank you.